Hello everyone, my name is Anders Subiria. I am researcher at Power Systems at Technalia Research and Innovation, and today I will explain you the introduction video on the basics of second life batteries as a starting lesson of the course 5 on second life batteries of the CISA project. So in this introduction video, you will learn the basics about second life electric vehicle batteries. For that, first we will explain some general aspects on second life batteries. Then we will show main components and their functionalities of these systems. Afterwards, we will explain the main second life battery reassembly processes. And finally, we will show some of the main configurations for coupling PV systems with second life batteries. In figure 1, you can see the main elements of a containerized second life battery system that is connected to a PV array and a EV charging station. So on the left side, you can see the EV batteries, which contain the lithium-ion cells into modules, the battery management system for safety management and monitoring, and the protection devices for the system. Next to them, we can see the inverter that converts the power to AC for grid or load feeding. Additionally, there's an HVAC connected in the container system to maintain temperature and a specific battery refrigeration system that is installed also to maintain safety temperature operation of the battery. The orange boxes are all software devices that manage not only the energy but also the communications. Additionally, it is needed to connect a PC or a computer that translates EV communications to interact with the rest of the system elements. Additionally, there's a SCADA system that links the grid with the PV array and the second life battery inverter. And lastly, there's a human-machine interface to monitor and manage all the systems in the containerized solution. Here are some general aspects on second life batteries. So as you know, retired electric vehicle batteries are still usable for several stationary applications like EV charging infrastructure support or coupling these batteries with renewable energy resources. This is mainly due to the reason that these batteries maintain 70 to 80% of the available capacity. Additionally, second life batteries help to avoid the depletion of critical and not abundant raw materials like nickel, cobalt, or lithium. In terms of costs, these second life batteries are in the range of 20 to 80% of the cost of an equivalent new battery, but there's uncertainty on the real energy capacity that this second life battery maintains. In terms of regulation, there's no standard yet for second life battery development. Nowadays, two main second life battery development processes are applied. One is based on direct use of the battery pack, so the battery is not opened and modules are not selected. And the second is based on opening the battery pack and selecting the most suitable modules based on state of health measurement. In figure 2, you can see a flow chart of the EV battery disassembly process. So, as you can see, the EV battery can be disassembled into different levels, going from using directly the battery pack, which is the option 1, to extracting modules, which is often option 2. And lastly, you can also disassemble these modules and take the cells for later analysis, which is option 3. It will all depend on the quality degree that you want to obtain for this second life battery. When coupling PV systems with batteries, three main configurations stand out. Figure 3. So first, AC coupling, where PV and batteries have their own DC-DC converters and inverter. This is a very flexible solution and allows to decouple energy flows coming from the solar system and the battery. Then there are two DC coupling options. The first DC coupling where PV and batteries have their own DC-DC converter but have a common inverter, which allows for a big efficiency of the system, and the MPPT coupling where the DC-DC converters are connected in series. So to mention that DC configurations provide high efficiency but make more complex to upgrade or retrofit the installation. For more valuable information on these topics, here you are some additional references. So this is the end of the introduction lesson. I hope you enjoyed. See you in the next lessons. Bye.